All right, so in section 3.4, we're going to deal with concavity. So you've heard of concave and convex. The issue with math is that we're looking at this in terms of a graph. And so what we're going to do is we're going to say concave up, which is going to be like a bowl. If it rains, it's going to hold water. Look at my little raindrops, okay? If it rains, it's going to hold water. That is concave up. If it is concave down, it's going to be like a mountain, okay? So if it were to rain, all the water would run off. So this is going to be concave down. Now, to introduce what we're doing, I've got y equals x to the third. So let's do what we did in section 3.3, and let's just determine increasing, decreasing maxes and mins. So if I take a first derivative, I get a 3x squared. Remember, your domain is all real numbers. I don't see any variables in denominators. I don't see any variables under radicals. So the only place I'm worried about for critical numbers is where my derivative equals 0. So I'm going to take this derivative, and I'm going to say, hello, what makes you equal 0? Okay, so divide both sides by 3. I get x squared is 0. Take the square root of both sides, and I get x is 0. So your critical number is 0. So if I slap that on a number line, now I can use test points. And remember, I'm going to put my test points in my first derivative. And this is going to tell me where it's increasing, decreasing, maxes and mins, change of direction, that type of thing. So if I grab a number to the left of 0, like negative 10. Okay, so negative 10 squared is 100. 3 times 100 is positive. So it's increasing to the left of 0. If I grab positive 10, positive 10 squared is 100 times 3 is positive 300. So we just found out that 0 is a critical number, but there's no change in direction. In fact, unless I restrict my domain, I do not have a max or a min because it's increasing for all eternity. So it will be, your lowest y coordinate will be somewhere in negative infinity, and your tallest y coordinate will be somewhere in positive infinity. So that brings up the question, why did this give me a 0 then? All right, so let's take this, which is going to be y to the first, or sorry, y prime is 3x squared, and now I'm going to take a second derivative. Okay, so my second derivative is going to be y double prime is 6x, and then my process is going to be the same. So take your second derivative, set it equal to 0, and solve. Divide both sides by 6, and lo and behold, you get x equals 0 again. So now what I want to do is test that in my second derivative. So I want test values in my second derivative. So this is just a little way that I keep track of what's going on. If I'm talking about first derivative and increasing and decreasing, I use arrows on the diagonal. When I'm talking about concavity, which is my second derivative, I use directly up and directly down arrows. And that's just a little visual for me to get reminded about where I'm at. Okay, so again, grab a number to the left of negative or of 0, so grab negative 10. 6 times negative 10 is negative. So I find out that I generated a negative number. I'm fixing to find out what that means. A number to the right of 0 is 10, so 6 times 10 is positive. So I have a positive answer there. So what does this mean? My second derivative will determine concavity. So if I draw my original function, which is x to the third, what he looks like is this and this. So again, he's increasing for his entire domain. I did not have a max or a min, but if you look at your second derivative, he's concave down here. Okay, so if it rains right here, all of it's going to run off. Okay, he's concave up here. So theoretically, it would hold water if it rains. So concave up and concave down. All right, so what does that mean? Where it changes concavity is going to be called your point of inflection. Okay, so now we know how to do this, so we're just going to dive in and do some examples. So first of all, for number 1, okay, I would like to know, I circle which ones I'm doing in this video. All right, so I would like to know what is the value of my first derivative. So if you read this going from left to right, do you agree that your function is going in a downwards or decreasing? So what is the value of your first derivative going to be? It's going to be negative. because your function is decreasing. So what that's looking for is f prime is going to be less than 0, which is where all the negative numbers live. Okay, what is the value of your second derivative? Well, my second derivative, look at the concavity of this thing, and it makes like a bowl shape, and so that means that this is going to be concave up, which means you should have positive numbers, so your second derivative will be everything bigger than 0, which is all the positives, okay? So now, let's just grab a couple. I know I want to determine concavity, so I'm just going to repeat myself a few times. I have my first derivative. First of all, this is a parabola that opens upwards. So my first, I'm going to come back over here, sorry. I got f of x equals x squared minus 3x plus 6 equals x squared minus 3x plus 6. Okay, so I want to determine concavity, which means I need a second derivative. So my first derivative is a 2x minus 3. That tells me increasing, decreasing, maxes and mins. Okay, my second derivative determines concavity, and holy cow, I got a 2. That means your second derivative is positive for its entire life. You cannot set this equal to 0. So think about what a parabola looks like. A parabola looks like this when it opens upwards because it's leading off positive. And so that means that you got a constant of 2, so he is concave up. So on the interval, where is he concave up? He's concave up from negative infinity to positive infinity. When is he concave down? Never. He is never concave down. So let's try number 3. I've got an x to the 4th. So f of x equals x to the 4th minus 7x to the 3rd. So I'm talking about concavity, which means I'm going to take 2 derivatives, minus 21x squared. Okay? So this one tells me increasing, decreasing, maxes, and mins. My second derivative is going to be a 12x squared minus 42x. Okay, so this is where I start setting stuff equal to 0. So take your second derivative, set it equal to 0. A number that goes into 12 and 42 is going to be 3. So if you would like to divide out of 3, you can. And so I'm going to divide out of 3 just to make my calculations easier. So that gives me a 4x squared minus 14x is 0. Oh, hey, look, a 2 comes out. 6 goes into both of these. So let's divide out of 2. That gives me a 2x squared minus 7x is 0. All right, so I would like to set this equal to 0 and solve. So I need to factor at this point. A number that goes into both of those is an x. So I'm left with a 2x minus 7. So where does this equal 0? At 0. And where does this equal 0? At a positive 7 halves. Which, I do that stupid. So a positive 7 halves is 3.5. Yes? So I've got 3 intervals that I've got to try. So a number to the left, and remember, you can use the cleaned up version of your second derivative as long as you have not divided by a negative, because that'll flip it and everything will be inverted from what you think. So all I've done is divide out positive numbers. So just for ease of calculation, I'm going to put my values in here. So I'm going to grab a negative 10. So 2 times negative 10 squared is going to be 200. Minus 7 times negative 10 is going to be plus 70. So I get 270, so he is concave up. Okay? And then between 0 and 7 halves, let's grab a 1. So 2 times 1 minus 7 is going to be negative, so he's concave down. And then 10 would be 200 minus 70. So he would be positive, so he's concave up. So when is he concave up? From negative infinity to 0. And again, from 7 halves to positive infinity. When is he concave down? From 0 to 7 halves. So you'd have a point of inflection at 0 and at 7 halves. Whereas in your first derivative, that would have been the location of a max or a min, and that would have been the location of a max or a min. All right, so let's do number 3. I just did. Let's do number 4. All right. So this one is slightly more exciting. This time I've got a variable in my denominator. So f of x equals 14 over x squared plus 3. So your first question is there a place where this is undefined? I cannot square a number to get a negative 3. Negative 3 plus 3 would be 0. So this is impossible. I cannot make my denominator equal 0. So right now my domain is all real numbers. Okay. First derivative, which would tell me increasing, decreasing maxes and mins. So I'm going to rewrite this as x squared plus 3 to the negative 1. You could do quotient rule if you want to. I don't want to. So drop your negative 1 out front times what's sitting there. Drop your exponent by 1 times the derivative of the inside. Okay, so you can leave it like this if you want to and do like a negative 28x and then do product rule for your second derivative. I'd rather clean it up and do quotient rule. Okay, so my first derivative cleaned up is I've got a negative 28x over, remember that drops down, so I've got an x squared plus 3 squared. So again, this would tell you increasing, decreasing maxes and mins. My second derivative, I'm going to use quotient rule. So I've got the bottom times the derivative of the top minus the top times the derivative of the bottom, which is a 2x squared plus 3 times 2x. And remember that gets raised to the first, all over the bottom squared, which is going to be to the 4th power. All right, so what have I got? The only way to make a fraction equal 0 is for its numerator to equal 0. Remember, I still cannot make my denominator equal 0, so I just really need to focus on my numerator. So, oh, good heavens, what do I have? I'm not looking ahead, so I'm just going to FOIL this thing out, which is probably going to be a waste of time. Actually, it is. All right, so I'm just going to rewrite my numerator. So he's an x squared plus 3 squared times a negative 28 plus 28x times 4x, okay, and I'm going to leave it like that for just a second, times 4x times x squared plus 3 equals 0. Now, the fun part is I can divide both sides by 28. So there's a 28 in this term, there's a 28 in this term, and that's just going to make my life a little bit easier. So that becomes a negative 1, and now that's gone. Okay, so what do I have? I've got an x squared plus 3 squared, and I've got an x squared plus 3. So let me rewrite this real quick. This one is going to be a 4x squared. Okay, 4x squared times x squared plus 3 minus x squared plus 3 squared is 0. And I can FOIL this out, I can combine like terms, I can do whatever. And that's probably what that's what I'm going to do. All right, so I've got a 4x to the 4th. I've got a plus 12x squared. I've got a minus, this is going to be x to the 4th, plus 6x squared plus 9, but I need to distribute that negative. So he's a negative, he's a negative, and he's a negative. Equals 0. So 4x to the 4th minus an x to the 4th is a 3x to the 4th. 12x squared minus 6x squared is minus a 6x squared minus 9. Divide out of 3. Okay, I'm fixing to run out of time. So I get an x to the 4th minus, divide out of 3, minus a 2. X squared minus 3 is 0, and I'm going to pause that and pick it up on the next one.